All right, today we are diving deep into the world of robotics. I mean, from the factory floor all the way to the surface of Mars, these incredible machines are changing our world in ways we are just, now starting to wrap our heads around.
And whenever you talk about robots, it almost always boils down to this one massive question, right? Are they coming for our jobs, or are they here to do the work that's just too dangerous, too difficult, or frankly, too far away for any human to even attempt? Let's dig in.
Okay, so before we can get to things like robot soccer teams or Martian explorers, we've got to start with the absolute basics. Let's just ask this simple question. What is a robot?
At its heart, the definition is actually surprisingly simple. A robot is just a machine that follows instructions. It's a tool, right? Guided by computer programs that we humans write, and it's designed to carry out a very specific task. But as we're about to see, those tasks can get unbelievably complex.
And this is what's so cool, the sheer variety of it all. The same basic idea, a programmable machine, can be an industrial arm welding a car door at crazy speeds, a rover kicking up dust on another planet, or even, a little robot playing a game of soccer. The form just follows whatever function we need it to do.
So this brings us to our first really big idea, the humanoid robot. It seems like we're a little bit obsessed with making machines that look, just like us. But why? What's the point?
Well, here's the fundamental trade-off. On one hand, it makes perfect sense. We build them in our image so they can operate in a world that was designed for us. They can open our doors, use our tools, you get it. But that resemblance is only skin deep. No matter how human a robot looks, it can't feel joy or love or fear. Its learning is just incredibly sophisticated programming.
And this really gets to a crucial point, addressing that classic sci-fi fear we all have. We are always, always in control. As one robotics engineer puts it, he's not worried about a robot takeover because at the end of the day, there's always an off switch. You can always just pull the plug.
And this whole desire to create a mirror image of ourselves, it can go to some pretty wild extremes. There's a professor in Japan, Hiroshi Ishiguro, who created an exact robotic copy of himself. He can actually send his robot double, his Geminoid, to meetings for him while he stays back in the lab. I mean, talk about working remotely.
Okay, let's pivot for a second. We've seen robots that are meant to mimic us, but what about the complete opposite? What about the robots that go where no human could possibly survive? These are the machines that become our eyes, our hands, and our feet in the most extreme environments you can possibly imagine.
So, meet the space climber. Its design isn't inspired by us at all. It's inspired by one of nature's best climbers, the spider. With all those legs, it always has multiple points of contact on the ground, which makes it incredibly stable. And that's perfect for its mission, climbing down into the steep, dark, treacherous craters on the moon, hunting for signs of frozen water. And you can see how this all works in practice. So in tests, the engineers will hide a target, in this case it was a little toy rabbit, inside a simulated moonscape. The robot scans the area with lasers, an engineer pilots it from a control room, and boom, mission accomplished. It's literally like playing the most high-stakes video game in the universe.
And this same idea applies right here on Earth, just deep underwater. Robots like this one, Dagon, basically act as our stand-ins. They dive hundreds of meters down to inspect wind turbines or conduct incredibly dangerous search and rescue missions under thick ice. These are jobs that are just way too risky for any human diver.
So, we've seen robots that look like us and robots that we pilot from afar, but this final piece of the puzzle, this is the real game changer. This is autonomy. What happens when the robot doesn't need a pilot anymore? What happens when it starts making its own decisions?
And you have to understand this is a massive, massive leap. We're going from a remote-controlled tool to a system that can actually perceive its environment, make a plan, and then execute that plan all on its own. The human is no longer in the driver's seat.
And believe it or not, robot soccer is the perfect place to see this in action. Here's basically how it works. Overhead cameras track every single robot's position on the field. A central computer acts like the team's brain, analyzing the whole game, deciding the best play in a split second, and then it just zaps out commands to the individual robots who carry out the strategy. It's like a hive mind on the field. It's amazing. And look, this isn't just some fun science fair project. This particular team of robots, built by students, actually placed 4th in the World Championship.
It just goes to show you how incredibly effective these autonomous systems can be when they work together as a team.
But of course, the technology isn't just for playing games. The exact same principles that guide those little soccer bots are being used right now in massive shipping ports. We're talking autonomous vehicles moving these gigantic containers around the clock 24/7 with no drivers, no brakes, no getting tired. It is the invisible backbone of our modern economy, running completely on its own.
And that really brings us back full circle to the big picture. We've seen robots as our mirrors, as extensions of our own bodies, and now as independent thinkers. As these machines keep evolving from simple tools that we control into complex partners that can think for themselves, the real question isn't just about what jobs they'll do. It's about how our fundamental relationship with the technology we create is about to change forever.